This is Poland. To the north is the Baltic Sea, an important waterway home to several ports and a connection for surrounding countries. Now take a look at this tiny sliver of land here between Lithuania and Poland. That's Kaliningrad, a Russian exclave that serves as the country's only ice-free port on the sea. The zone is causing a bit of tension with its neighbors when it comes to trade and travel. You see, for ships to access this port in Poland, they had to first pass through Russian-controlled waters, something that, after years of problems, Poland didn't want to do anymore. Along the freezing Baltic coastline of Poland, a canal less than 1.5 kilometers long sparked years of controversy across Europe. That canal is Vistula Spit Canal. At first glance, it appears to be just a waterway connecting Vistula Lagoon with Dansk Bay. But what Poland truly wanted to create was an escape from decades of geopolitical dependence. Before Vistula Spit Canal existed, every vessel entering the port of Elbląg from the Baltic Sea had to pass through the Baltic Strait, which is controlled by Russia. That meant Poland's access route to the Baltic Sea was effectively dependent on Russia. To change that reality, Poland decided to spend $450 million to cut through a nearly 70 kilometers long Baltic sand spit and create an entirely new route to the sea. In today's video, join Danger Zone as we explore how a tiny canal became one of the most symbolic geopolitical infrastructure projects in modern Europe. Vistula Spit Canal is located in the Neuschwadt area in northern Poland, cutting through the narrow strip of land that separates Vistula Lagoon from Dansk Bay on the Baltic Sea. The structure is approximately 1.3 kilometers long, more than 120 meters wide, and about 5 meters deep, allowing medium-sized vessels to travel directly from the sea into the lagoon without passing through the Baltic Strait in Russian territory. The project began construction in 2019 by the Besix and NDY Construction Consortium, opened its first phase in 2022, and continued completing infrastructure works in the following years. In addition to the main canal, the entire system also includes a 270 meters long lock with 4 gates weighing approximately 160 tons each, 2 breakwaters, a movable bridge, and a modern maritime control center. However, the greatest value of the Vistula Spit Canal does not lie in its engineering scale or shipping capacity. For Poland, it is also a strategic project that allows the country for the first time to fully control access to and from the Vistula Lagoon, without depending on a maritime route controlled by Russia in the Baltic region. The excavation of the Vistula Spit Canal was considered the most important and complex phase of the entire project. The construction site was located on a coastal sand spit with weak geology, highly vulnerable to erosion, and constantly exposed to waves from the Baltic Sea, making construction especially difficult. To open the canal route through the sand barrier, contractors deployed dozens of large hydraulic excavators operating continuously along the site. Layers of sand, mud, and sediment were excavated and transported by heavy dump trucks to nearby coastal areas. Instead of being discarded, this material was later reused as foundation fill for artificial islands and the breakwater system that would be constructed in later phases. At the same time, engineers had to implement multiple shoreline stabilization measures to prevent sea waves from eroding the construction site. Hundreds of steel piles were driven deep into the sandy ground along both sides of the excavation route to reinforce the terrain and reduce the impact of water flow throughout the construction process. Next, ground stabilization using the deep viro compaction method was considered a critical engineering step to ensure the long-term stability of the entire structure. After all soil and rock materials were removed, the slopes were reinforced with geotechnical mesh and covered with a layer of saline soil to help reduce erosion. The excavation and ground stabilization phase alone lasted for many months, turning the area into one of the most complex coastal construction megasites in Poland at that time. After the canal route gradually began to take shape, the focus of the construction site shifted to building the breakwater system protecting the canal entrance on the Baltic Sea. These breakwaterators served as the protective barrier that would allow the RO to survive long-term in the harsh marine environment. Construction began with the formation of the breakwater core using sand and fill materials recycled from the earlier canal excavation phase. Thousands of tons of material were continuously transported to the sea entrance to create the initial foundation for the breakwater system. Once the breakwater core had been formed, workers continued driving large numbers of steel piles deep into the coastal sandy ground in order to precisely define the alignment and shape of the entire breakwater system. These steel piles also acted as a temporary reinforcement framework, helping stabilize the structure against strong Baltic Sea waves and currents. Next, concrete and reinforcement structures were poured and installed along the steel sheet pile line to secure the shape of the breakwater and increase the load-bearing capacity of the entire structure. Thanks to the steel framework combined with concrete reinforcement, the breakwater could maintain long-term stability against constant wave pressure. This was followed by the dredging and stabilization of the underwater foundation in order to create a stable base capable of supporting the entire breakwater system at the canal entrance. Afterward, massive concrete blocks were installed on the outer side to reinforce the structure. These components were designed with hollow gaps and openings in the middle to reduce the pressure of waves and water currents directly impacting the breakwater, thereby increasing the long-term stability of the entire canal entrance. At the same time as the breakwater construction, the excess sand continued to be used to form an artificial island near the canal entrance area. Initially, the island was only a circular sand formation approximately 5 kilometers wide in the middle of open water. Over time, however, it was gradually expanded with additional layers of soil, rock, and film materials transported from the construction site, before eventually becoming a new ecological habitat for coastal birds to nest and live. Once the canal excavation and breakwater system were largely completed, construction of the lock system, the most important structure of the entire project, began. First, in order to create a dry construction area, workers installed parallel double-layer steel and concrete walls surrounding the future lock location. Between the two wall layers, additional reinforcement was added using a system of heavy steel diagonal anchor braces, helping stabilize the foundation throughout the construction process. At both ends of the lock, massive steel gates weighing hundreds of tons were installed and operated by a hydraulic system capable of completely sealing the chamber in order to raise and lower water levels as vessels pass through. Inside the structure, groundwater regulation pipes and automatic valves helped maintain stable water flow without creating turbulence. The entire process was managed through a network of sensors and an electronic control center. Thanks to the application of modern engineering technology, the Vistula Spit lock operates with high precision, withstands major water level differences and harsh climatic conditions, and became the engineering heart of the entire canal system. Finally, the various construction components gradually began to merge into a fully integrated operational system. Alongside the completion of the navigation channel and the stabilization of the entire canal, the surrounding road network was also brought into synchronized completion. The system includes 2 swing bridges crossing the canal, each capable of rotating 90 degrees around a central pivot point. Whenever a vessel prepares to pass through the Vistula Spit Canal, the automated control system activates and the bridges rotate sideways one after another, creating enough clearance for ships to move safely through the canal before returning to their original positions so road traffic can continue flowing normally. Given the relatively narrow geography of the Vistula Spit, integrating swing bridges into the overall operational system was considered an efficient engineering solution, helping optimize space while minimizing traffic disruption between the two sides of the canal. Thanks to the combination of maritime infrastructure, automated mechanical systems, and a synchronized transportation network, the Vistula Spit Canal gradually transformed from a complex coastal construction site into a modern transportation complex capable of operating reliably over the long term in the harsh Baltic environment. The Vistula Spit Canal is not only a maritime infrastructure project, but also carries major strategic significance for Poland in terms of sovereignty, security, and geopolitical influence in the Baltic Sea region. First, the canal allows Poland to regain full control over access to and from the Vistula Lagoon, eliminating its previous dependence on the Baltic Strait controlled by Russia. This carries not only economic importance, but also symbolizes the country's maritime independence and strategic autonomy. In terms of security and defense, the canal enables Polish patrol and logistics vessels to move directly between the lagoon system and the Baltic Sea without passing through Russian waters. As tensions between NATO and Russia continue to rise, the project has become a new strategic connection point in the Baltic region. Meanwhile, Russia strongly opposed the project, arguing that the canal could be used by NATO for military purposes and could affect security in the Baltic Sea. Several European institutions also called for additional reviews regarding environmental impact and regional security concerns, which prolonged the approval process. However, Poland consistently maintained that the canal was a civilian project intended to restore maritime independence and support regional economic development. In addition, the project has helped restore the role of the port city of Elim, while encouraging investment in logistics, tourism, and infrastructure across northern Poland. At the same time, it clearly reflects Poland's ambition to strengthen its maritime position and reduce geopolitical dependence through technology, infrastructure, and national self-reliance. Could NATO use the canal? As tensions between NATO and Russia continue to shape security policies across Europe, the Vistula Spit Canal has attracted attention far beyond the borders of Poland. Officially, Poland has always described the canal as a civilian infrastructure project designed to improve maritime access, strengthen regional development, and eliminate dependence on a foreign-controlled shipping route. However, from the moment construction began, many observers questioned whether the project also carried strategic military value. Before the canal existed, vessels operating inside the Vistula Lagoon could only reach the Baltic Sea through the Baltic Strait, a waterway controlled by Russia. This meant that any disruption, restriction, or political tension could potentially affect Poland's maritime access in the region. The new canal changed that equation completely. For the first time, Poland gained a direct route between the lagoon and the Baltic Sea without relying on a passage controlled by another country. While the canal was primarily designed for commercial and civilian traffic, military analysts quickly noted its potential strategic implications. In peacetime, the canal can support regional shipping, tourism, and local economic activity. But in times of increased regional tension, the same infrastructure could provide additional flexibility for patrol vessels, Coast Guard operations, emergency response units, and logistical support missions operating within Polish territory. This possibility immediately raised concerns in Moscow. Russian officials argued that the canal could eventually support NATO-related activities in the Baltic region and become part of a broader effort to reduce Russian influence over regional transportation routes. Poland strongly rejected those claims, insisting that the project was never intended as a military facility. Yet modern infrastructure often serves multiple purposes. A road can support civilian traffic while also moving military equipment. A railway can transport commercial goods while providing strategic mobility during emergencies. The same principle applies to maritime infrastructure. As a result, the Vistula Spit Canal became part of a larger debate surrounding security, sovereignty, and strategic resilience in Northern Europe. And to understand why Russia paid such close attention to this relatively small canal, it is necessary to look at one of the most heavily fortified regions in the Baltic Sea, the Russian fortress on the Baltic. That region is Kaliningrad. Located between Poland and Lithuania on the Baltic coast, Kaliningrad is a Russian exclave, separated from mainland Russia by hundreds of kilometers. Although relatively small in size, it has become one of the most strategically important military territories in Europe. The region serves as the headquarters of Russia's Baltic Fleet and hosts a large concentration of military infrastructure, including naval facilities, air defense systems, radar installations, missile units, and strategic command centers. Over the past 2 decades, Kaliningrad has gradually evolved into one of the most heavily militarized areas anywhere along the Baltic coastline. Its location gives Russia a unique strategic advantage. From Kaliningrad, Russian forces can monitor maritime traffic across large sections of the Baltic Sea, while maintaining a permanent military presence close to several NATO member states. For many Western security analysts, Kaliningrad functions as a forward military outpost that allows Russia to project power deep into northern Europe. The importance of the region becomes even more apparent when examining another critical location known as the Suwalki Gap. This narrow corridor of land stretches between Poland and Lithuania, connecting the Baltic states to the rest of NATO territory, while separating Kaliningrad from Belarus, one of Russia's closest allies. Military planners on both sides consider the Suwalki Gap one of the most strategically sensitive areas in Europe. In any future regional crisis, maintaining access through this corridor would become critically important. Against this backdrop, even relatively small infrastructure projects can take on much greater geopolitical significance. For Poland, the canal represents an opportunity to reduce strategic dependence and strengthen national control over maritime access. For Russia, however, the project symbolizes another step toward limiting Moscow's influence over transportation routes in the Baltic region. This is why a canal measuring only 1.3 kilometers in length generated years of political debate, diplomatic criticism, and international attention. Its true significance lies not in its size, but in the strategic environment surrounding it. Beneath the concrete, steel, and engineering systems lies a broader story about power, influence, and control in one of Europe's most sensitive geopolitical regions. The environmental battle. Despite its strategic importance, the Vistula Spit Canal also faced environmental criticism throughout the planning and construction process. Environmental organizations warned that cutting a new waterway through the Baltic sand spit could affect bird migration routes, alter lagoon ecosystems, and potentially impact local fish populations. Several European institutions requested additional environmental reviews before construction moved forward. Polish authorities responded by introducing environmental monitoring programs and creating new habitats using excavated materials from the construction site. Supporters argued that the long-term impact would remain manageable, while critics continued to question the project's ecological consequences. As a result, the Vistula Spit Canal became more than an engineering or geopolitical project. It also became an example of the ongoing challenge of balancing national infrastructure ambitions with environmental responsibility. Compared to other famous canals around the world, the Vistula Spit Canal is clearly not the largest or the busiest. However, what makes it unique lies in its strategic significance and national symbolism. In Egypt, the Suez Canal is one of the most important maritime routes in the world, connecting the Mediterranean Sea with the Red Sea and allowing ships to travel directly between Europe and Asia without sailing around the Cape of Good Hope. Opened in 1869, the canal stretches for more than 190 kilometers and now handles nearly 12% of global trade traffic, with tens of thousands of vessels passing through each year. Beyond its enormous economic value, Egypt's nationalization of the Suez Canal in 1956 also became a symbol of the country's effort to regain control of strategic infrastructure from foreign influence. Meanwhile, the Panama Canal serves as a bridge connecting the Atlantic Ocean and the Pacific Ocean. Completed in 1914, this canal, stretching approximately 82 kilometers, allows ships to avoid sailing around the southern tip of South America, shortening international maritime routes by thousands of kilometers. Panama's system of 3 massive lock complexes enables vessels to be lifted across an elevation difference of more than 26 meters between the oceans and inland lakes. After more than a decade of cutting through mountains and jungle, moving hundreds of millions of cubic meters of earth and rock, building gigantic lock systems, and paying the price with the lives of tens of thousands of workers, the Panama Canal officially opened. This became one of the most expensive and ambitious engineering projects in the Americas, with a total cost equivalent to more than $10 billion today. And from that moment on, this waterway permanently reshaped global trade. Following the expansion completed in 2016, the canal became capable of accommodating ships with capacities of up to approximately 170,000 deadweight tons, continuing to maintain its role as one of the world's most strategically important shipping routes. But the greatest difference of the Vistula Spit Canal does not lie in its length, shipping volume, or commercial scale. For Poland, the project carries a far more significant geopolitical meaning. It is not simply a new waterway, but a statement that Poland can create its own independent access to the sea without relying on any maritime road controlled by another country. Although only 1 kilometer long, the Vistula Spit Canal has still become one of the most strategically significant infrastructure projects in the Baltic region in recent years. Behind the layers of concrete and steel lies a broader story about the effort to assert national sovereignty amid growing regional tensions. The Vistula Spit Canal is not only an engineering achievement, but also a symbol of self-reliance, where a small nation dared to cut through its own land to create an independent route to the world. What do you think about whether the Vistula Spit Canal was truly a necessary strategic move for Poland? And if you want to continue exploring mega infrastructure projects like this, keep following us.
Friends, if you enjoyed the video, don't forget to give it a like and subscribe to the channel. Your feedback is our inspiration, so let us know in the comments how you like the video.